Okay. Okay, so it is going. All right, awesome. Okay, so first of all, welcome back from winter break. I'm looking forward to getting to see you guys tomorrow. So we're starting chapter 6. We're going to pull in some things from what we did before Christmas break a little bit. So first of all, we're doing 6-1, 2, and 3. We're kind of spending 3 days on it. So it's going to be a little mixture of a lot. But today we're just going to focus on perpendicular bisectors and angle bisectors. So what conjectures can you make given special segments of a triangle? So what you're going to learn is to identify and make conjectures for special segments. They're called special segments because if you'll notice, there are 4 different pictures here. And in those 4 pictures, there are special properties about each one of them. I do expect you to be able to identify them on site, okay? So first thing we're going to do, we're going to write the letter with the name of the segment, line, or ray that's shown. So first off, you have to make sure you're looking at the tick marks that are provided in each picture. In this first picture, the only marking that we have is that this is a right angle. So we all know from the past, whenever we had a triangle and we have a base and a height, okay? So we're able to find the area if we know the base and the height. So this segment that's inside here is called the altitude because the altitude is a fancy name for height. In this picture here, I see that this piece is equal to this piece here. So this part is equal to this part. Therefore, this is a midpoint. Okay, so this is a midpoint. So since this is a midpoint, the vertex is connected to the midpoint. All right, so when the vertex is connected to the midpoint, this is your median. Now, in this one, it's kind of a combination of these two in a way, because this piece is equal to this piece, just like here. And then we have the right angle just like here. So when you see both of them together, this is what's called a perpendicular bisector. So this is a perpendicular bisector. And then this one, when you see the angle marks congruent, this is your angle bisector. So if you'll just pay attention to the markings, it gives it away as to which one it is, okay? So the first one we're going to look at is the perpendicular bisector theorem and its converse. So this says if line CP, so line CP is this line right here, is the perpendicular bisector. So they're telling us that this CP is the bisector of here. So that means that AP is congruent to PB. It also means that CA, which is this piece here, is congruent to CB, which is this piece here. So now it says, which triangle congruence postulate, so side, 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 angle, or angle, angle, side. So which triangle congruence postulate also proves that this CA is equal to CB if CP is the perpendicular bisector. So if you look at this, we know that in this one large triangle, CAB, that when you draw a line CP through here, this is equal to itself. So we could use side, because this side is equal to itself. So we're going to go side. This is a right angle, so that's angle. It's a right angle on this side also. And then we have this side here. So side, angle, side allows us to say that this is equal to this by CPC-TC. Now the converse says that if DA is equal to DB, so if this is equal to this, then point D lies on the perpendicular bisector. So if I were to extend this line right here, because they're telling us that PA and PB are equal, and they're telling us that that's a right angle. So that makes this right here a perpendicular bisector because it's 90 degrees at the midpoint. So therefore, if CP is the perpendicular bisector, then these two sides will be equal. And if these two sides are equal, in other words, an isosceles triangle, then this is the perpendicular bisector. Okay, so using that thought process when you're looking at a picture trying to solve a problem algebraically, then you're going to use those two theorems. All right, so find the indicated measure. So they want us to find AB. So AB is this piece right here, and they want me to find that. So what I do is I look here and I'm like, oh, these are both 6. So this is equal to this. This is 90 degrees. So this is a perpendicular bisector because it's 90 degrees at the middle. So if this is 9, then this is 9. This time they want me to find SU. So SU is this piece right here. So if they're wanting me to find SU, then that means I'm going to have to find X and plug it back in, okay? So since these two are equal, then that's the converse because they're telling you, hey, if these two are equal, then that means these two are equal. So that means that 3x is equal to 2x plus 2. So I'm going to subtract 2x from both sides. And for those of you that need the extra line through there, so this is x equals 2. So if x is 2, well, 3 times 2 is 6. 2 times 2 plus 2 would be 4 plus 2. That would also be 6. So that means that SU is 6. And make sure you're following through and answering the question that it's asking and not stopping too soon. All right, the next one we're going to look at is the angle bisector theorem, and its converse. Works the same way. If AD bisects the angle, so if this is your angle bisector, then, let me back up. If this is your angle bisector and DB is perpendicular and DC is perpendicular, then DB, this piece, is equal to this piece. Okay? So which triangle congruence postulate could also be used to prove? Well, we know this is equal to itself, right? So if we're trying to prove that this is equal to this, then we need to prove that these two triangles are congruent to each other. Well, I have a right triangle, and I have these two angles right here, and then I have these two angles right here. So I could say angle, angle, side. Okay, so angle, angle, side. Let me mark that. Angle, 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 side. Put my A in the wrong place. All right, so angle, angle, side, angle, angle, side. Same thing in reverse. If these two pieces are equal and perpendicular to the sides, then this is equal to this. So BAD is equal to CAD, just the same. So look for the markings. If these two angles are equal, then this is an angle bisector, and these two these two angles are also congruent and 90, then these two will automatically be congruent to each other. And if they are congruent and these two are still right angles, then these two are going to be equal. So just kind of look for those marks. So if I look at this picture and they want me to find BD, so they're wanting me to find BD, which is this piece right here. So I know that if these two angles are equal, then these two sides are going to be equal to each other because of these right angles, right? So because of angle, angle, side, because this piece is equal to itself, so that means that 3x plus 1 is equal to 5x minus 1. So if I solve for x, because I'm going to need to plug it in, so I'm going to subtract 3x from both sides. So 1 is equal to 2x minus 1. Add 1 to both sides. 2 is equal to 2x. Divide both sides by 2. X equals 1. Okay, so x is 1, but that's not what they want me to find. They want me to find BD. So 3 times 1 plus 1. So 3 times 1 plus 1. So 3 plus 1 is 4. So BD is 4. All right, now this last part. So what we're going to do is we're going to write equations for perpendicular bisectors. So you're going to have to write an equation. So I'm going to need a y equals mx plus b kind of thing going on here. All right. So if you'll follow the steps, Okay, there's only 3 things that you have to do to write a perpendicular bisector. So the first thing you're going to do, 2 lines intersect to form right angles. So if 2 lines intersect to form right angles, then that means you need their slope. Okay, so slopes are opposite reciprocals. So first thing you're going to do is find the slope and then find the perpendicular slope. So find the slope. So part A is find the slope. Part B is find the perpendicular slope. So we need opposite reciprocals. Okay. Find the slope and find their opposite slope. So then the bisector part tells me this is your midpoint. Okay, so that means now I need to find the midpoint. So remember your midpoint, add the 2 points and divide by 2. So you add your x's, divide by 2, add your y's, divide by 2. And then for slope, don't forget, and all this is on your formula chart. So y2 minus y1, x2 minus x1. I'll just write those on there, even though they're on your formula chart. So step 1, find your slope, and then the perpendicular slope. Step 2, find your midpoint. And now write an equation. So what you're going to be using, the perpendicular slope and the midpoint. Okay? So you'll plug them into this formula right here. So you'll plug them into that formula right there. All right, so with that said, let's find the equation of the perpendicular bisector of AB. So the first thing I want to do is I want to find the slope of AB. So remember your slope is rise over run. So I'm going to go rise and I'm going to go run. So how many do I go up? 1, 2, 3, 4. So I went up 4 and I went over 2. So my slope, and I'm going to use this space over here. So my slope is 4 over 2. So that means my perpendicular slope is negative 2 over 4, which is negative 1/2. Okay, don't worry about reducing it until you're done. All right, so this is the slope that I'm going to use because it says to use the perpendicular slope. So this is the slope I'm going to use. Step 2 says to find my midpoint. So the midpoint of this. So I'm going to use this part up here. So my midpoint, oops, that slope, sorry. My midpoint says to add the x values. So point A is at 0, negative 2. Point B is at 2, 2. So if they don't give you the points, then just look on your grid and get them. Okay, so I'm going to add the x values. So 2 plus 0 divided by 2. So 2 plus 0 is 2. 2 divided by 2 is 1. So my midpoint is located at 1. And then do the same thing with the x value or the y values. So that's going to be 2 plus negative 2 divided by 2. Well, 2 plus negative 2 is the same thing as 2 minus 2, which is 0. So there's my midpoint. So now, and what I'm going to do real quick, because it kind of messed up, I meant to do the midpoint up here. So let me just mark this out really quick, and I'm going to do this, finish this problem in this space right here. All right, so now what I'm going to do is using this formula is I'm going to use this slope and this point. So y minus y1 okay, equals slope, negative 1/2, x minus x1. Okay, so now y minus 0 is still y, and then distribute the negative 1/2. Negative 1/2 x, a negative times a negative is positive, and that's 1/2 x. So there, oops, is your equation of your perpendicular bisector. Okay, so find your slope, flip it, find your midpoint, plug it in. It seems like a lot of work, but once you've done it a few times, it's really not, I promise, and you will be fine. So now we're going to write the equation of a perpendicular bisector of a segment with endpoints P and Q. So we're going to follow these steps up here. So the very first thing we're going to do, so part A, we're going to find the slope. So find the slope. So the slope formula is y2 minus y1 over x2 minus x1. Or you can draw a grid, do it on a grid, and do it that way. I'm going to go ahead and do it by hand here. So this is going to be 3 minus 1 and negative 2 minus 4. Okay, so this is my x1 and my y1. This kind of got off skewed a little bit. x2 minus y2. There we go. So 3 minus 1 is 2 over negative 6. So 3 minus 1 is 2. Negative 2 minus 4 is negative 6. So that's my slope. So my perpendicular slope, because that's the part B that I was talking about here. So flip it. So the perpendicular slope is positive 6 over 2, which is 3. So this is the slope you're going to use. Sorry, I did not realize I was getting out of screen there. All right, so now you're going to use 2 over negative 6 becomes 6 over 2. So remember, perpendicular slopes have to be one positive, one negative. So here is the slope we're going to use. And now you're going to find the midpoint. So now find your midpoint. So midpoint, add the 2 points together. So negative 2 plus 4 over 2. So negative 2 plus 4 is 2. 2 divided by 2 is 1. And then do the same thing with the y values. 3 plus 1 over 2. 3 plus 1 is 4. 4 divided by 2 is 2. So my midpoint, that looks terrible. My midpoint is 1, 2. So here's the point and slope that we're going to use. And then we're going to plug it into this formula again. Y minus y1 is mx minus x1. Okay, we're still using this formula. Here's your m, here's your x1 and your y1. So now we got y minus 2, 3x minus 3. Add 2 to both sides. Y is 3x minus 1. And that is it. And you are done. And I will see you guys later.